Winnie, did you just leave your hand up, or you want to share something?
No, it is just accidental.
It's okay. Okay. I will request that we behave like we have always done. Mute our mics. Winnie, mute now. When you want to speak, you put up the hand and then speak to us. I was still finding out. Do you know where we stopped? Can I have someone remind us of what we did last time? Can I have someone talk to us? I just want to know whether you are with me. Should I go alone? What did we do? Or what have you tried out as you that you can share with us? Yes, Innocent.
Yes, last time we did some numerical work about the equation of perpendicular vectors and the angle between two vectors.
Good.
We saw
yes,
that.
Continue.
Yeah, we saw that for any two vectors, if they are perpendicular, their dot product is equal to 0, since the angle between them is 90 degrees. And
very good.
I personally, I went on and studied some bit of other vector algebra, like showing that two vectors are collinear, since I had gained some knowledge from here that when two vectors are in a straight line, one is a scalar multiple of the other. So I used that knowledge and learned how to show that two vectors are collinear and also whether they are parallel. But we had agreed that we are going to study about the vector equation
of a straight line.
Yeah. But
thank you very much for that, Innocent. Okay, before I bring in the vector equation of a straight line, I want each one of you to give me these answers to this example here and very fast. I hope you are there and you can get the example very fast, and then we go through it, and then we can then continue with our work. Someone is about to say we are not seeing your screen. Okay, I'm sharing my screen. When you get to see my screen, you let me know. Have you seen my screen now?
Yes, sir, I've seen it.
Okay. I am giving you just a few minutes. Let me 3 minutes. Then you give me your work on that, and then we can continue.
Eyo Jimazi.
Joanne, what can't you see? Joanne, open your mic and let me know where your problem is. But I can I think that is better. That one who is just coming in, please, we are trying out this example very fast and then connecting and continuing the vector equation of a straight line. Okay, is anyone ready? Is anyone ready? I'd be glad if someone took us through very fast. Okay, if you have started on it and you have seen the way to go still, you can guide us. Someone who is there. If you have started on it and you have seen the way to go, can you tell us how we should continue? Yes, Sama who? Sama.
Thank you,
What is
sir.
your name? Yeah, what is the name?
My name is Zamarano, but it's Zama.
Zama. Zama, go ahead and guide us.
Good afternoon, sir.
Good afternoon, Zama. You are in class, so you are greeting everyone, not me alone.
We have been given the point of this here. In us to show that ST is perpendicular to BT. So what we can first do is to first get our SC.
Beautiful. Wait a little. Okay, continue.
We get our SC by having the position vector of C minus 1 for A. C, which is OC minus OA.
OC minus OA. And what is OC minus OA in our work?
It's 7 minus negative 2.
It is 7, take away negative 2. That is I. Or you have used column vectors.
Yes, I use column vectors, but we can continue with them. I have also 6 minus 3.
Good. That is J. And what is our final here?
9.
9. Yes, plus
3J.
Okay. Then what else do we do?
Also get 1 for BD.
We also get the vector BD. Beautiful, Zama. I think I like that. Please go ahead and give us BD.
Then BD will be 7. I think 7.
7 minus
3.
3. That is I. And then what else?
Then I think negative 4.
Negative 4. Minus
8.
Minus
8.
8. Can't you see now?
Good, minus 8.
Then the
And
final
when you
answer
simplify, what does it give to us?
for I.
Sorry about that. For I,
12j.
take away 12j. After getting those vectors, how do we show that they are perpendicular?
We get their dot product, multiply
Beautiful.
them.
Beautiful. Get the dot product. And our dot product here, SC dot BD is going to give us 9I 3j. And this dots for I minus 12j. And when you continue, what do you get?
0. 36. 9 times 4.
It is 9 times 4, which is?
36.
36. Remember 9 times 12. What value do we get when we take 9I times negative 12j? 9I dot 12j, what will it give to us?
Negative 108.
It is 0. Why 0? Because I dot j
They are
is
perpendicular.
0. Those are perpendicular. Very beautiful. Can you now go ahead? Then take a j and j. And j and j is 3. Take out 3 multiplied by negative 12, which is also negative 36. Is that right? And this finally gives us a 0. And because we are getting the dot product of SC, there I expect you to conclude. Because the dot product of SC, because SC dot BD is 0, SC is perpendicular to BD. Is that fine? Since SC dot BD is 0, then we can conclude that SC is perpendicular to BD. SC perpendicular to BD. Very good. Thank you very much. There are people who are coming in and do not close the mics, and then they start discussing with other people. Please, let's learn to behave in class. Let's learn to behave in class. It's good manners to be disciplined. Close your mic. Ambrose, can you close the mic? Thank you so much, Zama, and those who assisted a little bit here and there. Ambrose, close the mic. Can we now continue? Of course, I want you to go through that number there. Let me share it. So that you will just take a shot of it, then you will try it out. But then I am going to get to something different. Victor, please close your mic. Victor? Okay. Can you see the question that I want? No, I haven't yet moved to the one that, can you see the question that I want you to try out? Please take a shot of it, then you will try. It's an exercise. It's a question from the exercise, but I think it's one of those beautiful questions that show your mastery of what we have discussed. Please go ahead and try it out. There's also another, for those who don't have the book, those who have the book, the question is very clear. I picked it with its number. It's number 22. of that exercise. Now you ask me which exercise it is. Is it 2C? I think it is 2C. Okay, I can then go to the next, that is also exercise 2C. You can take a shot and you will try out. I looked through a few of those numbers and I found that they are just giving you the ideas that we have, they are concretizing the ideas that we have shared here. So please do not just ignore them. Look at them seriously. Then if you have finished, then you can also take a shot of that one and you go through that. Then you will see. Oh, did I mute you? I don't think I muted you. You can always unmute and talk and then mute. Someone is saying, sir, unmute us. I think you are not muted. But check if you are muted, I'll unmute you. Just put up the hand. I'll get to know that you are muted because you can't speak. But I think people can speak. I didn't mute anyone. Okay, we can, I think, move on to our lesson today. Unless you have a comment, if someone is saying I muted you, I told you, please do put up your hand so that I get to know. Otherwise, may I expect that you can unmute. Okay, let's go to today's lesson. Okay, the vector equation of a straight line. May I get a volunteer to read for us the statement? The vector equation of a straight line. Winnie?
I read the whole question.
Please read the question. No, it's not a question. That text there.
Oh, the vector equation of a straight line.
Yes.
A straight line is uniquely defined if we are given the position of one point that lies on the line and the direction of the line. In terms of vectors, this means that a line is defined if we know a vector that is parallel to the line and the position vector of a point on the line. Consider the line which passes through a point A, position vector small a, and is parallel to A vector B. To find the vector equation of this line, we consider some general point R on the line. Suppose R has position vector small r.
Thank you very much. What I may repeat is that when we have a straight line and we know the vector parallel to that line, and we have one point on that line, the position vector of that point, then we can give the vector equation of the line. Here we are given a chance. Let me share this screen here. Then you will see the diagram, which is also, which I am picking from that other worker there. So our line is the line AR. You are going to ask me, where is R? I can't see the R, but I can write R here. Our line is the line AR, that's the straight line whose equation we want to find. This straight line is parallel to a vector B, as you see in the diagram. One point on this line is the point A, whose position vector is vector A known. Now we are taking R to be a general point on the line. So R can keep changing positions. R is a general point on the line, and so it can be anywhere on the line. And that R is what defines the equation of our line. So what is the vector equation of the line? From this diagram here, and from what we have just assumed, or from what we are taking, the vector AR is parallel to the vector B, because B is parallel to the line, and AR, A is a point on the line, R is a point on the line. Now, may I have someone to remind us, when two vectors are parallel, what do you know about them? When two vectors are parallel, yes, Innocent?
Two vectors are parallel. One is a scalar multiple of the other.
Very good. So we can comfortably say that if AR is parallel to the vector B, then AR is a scalar multiple of vector B. And I am taking my scalar to be lambda. And why choice of lambda? You can choose any other, but I'm making the choice of lambda just because many of the books that you're going to use to read have the scalar lambda. And so when you get used to it, it will be easy to read. But please, this is just any scalar, and you can put any scalar. Okay, what is AR? Vectorically, vector AR equals to what? Can someone define for me how we can define vector AR? Anyone? Ruth?
Vector AR equals to...
Come again?
I'm saying vector AR equals to OR minus OA.
Beautiful. That exactly is what I wanted. So this will imply vector OR minus vector OA. And what is it equal to? It is equal to lambda B. Where is our origin? Our origin is that point somewhere there on our diagram. That is the origin. So what is vector OR? From our diagram, vector OR is?
R.
Very
Small
good.
r.
Very good. Vector OR is the vector small r, and vector OA?
Small a.
The vector A. So vector R minus vector A is the lambda B. And finally, I can make my R the subject of this, and R is equal to A plus lambda B. Now I want to congratulate each one of you upon having obtained the vector equation of the line. This R is A minus, R is the A plus lambda B is the vector equation of the line. I want to congratulate you for having obtained the vector equation of the line. So what do I need? The moment I know the vector A, which is the position vector of the point, 1 point on the line, and I know the vector B, which is the vector parallel to the line, then I can write my vector equation of our line. Do you have anything to comment at this point before we continue? Any comment? Sorry about that. Any comment?
For me, I'm lost on that very first step.
Please come again. Where are you? Why? What is the problem? Why are you lost? What is it that you are not seeing? We had a few words that came before this.
Sir.
What words did we have that came before this? We said that suppose if we supposed, let me pick that work again. We said that consider a line which passes through a point A, whose position vector is A, and is parallel to the vector B. To find the equation of this line, we consider some general point on the line and suppose that this point is R with the position vector R. So when we got that diagram there with our line, or the diagram of our line showing our straight line, which straight line is passing through point A, whose position vector is A, and which straight line is passing, and we consider the general point R on that line. And like I have said, since it's a general point, it can be anywhere on this line. So with the position vector R, if we have that, then we agreed that, then it means that our line AR, we said vector AR, which is on the line, is parallel to B. And then we used the definition of parallel vectors. When vectors are parallel, I don't know whether it was Innocent who told us that one is a scalar product of the other. So we said AR is therefore the scalar product of B. We took our scalar to be lambda. And when we took...
I'm sorry that even if you stop from there, thank you.
Oh, Ambrose, you have now picked? You
Yeah.
have connected. Very good.
Yeah.
I'm continue. Continue.
You continue. For us, we have just joined.
Okay. Let's continue. Please behave as we continue. Now, I was already congratulating you upon having obtained the vector equation of the line. Now, what is it that I can say here? Do I have anything? Can't I give you an example? Oh, I can. Let us have an example and see what I am talking about.
Yes, go ahead.
I go ahead. There you are.
Yeah.
Can someone read for us the example? I picked it as example 17, the way it is in the book. I don't remember the page, but example 17, you can check the page. I can also check, but something, page like 20 something there. No. 60. Okay. Kato, take us through. Kato, as Technosparker 4, please rename so that I get to know your name. Technosparker 4, whose hand is up? Please rename so that I get to know your name. You are people who know technology. You should be able to rename. And that is good. We need it here. Kato, it's your floor.
Find the vector equation of the line that is parallel to the vector 2i minus j, and which passes through the point with vector position 3i plus 2j.
Can you read it properly? The point with?
Through the point with positioning vector 3i plus 2j.
Thank you very much. It is position vector of a point, not vector position. Okay, that's what I was trying to make clear, Kato. Okay, thank you, Kato. Mami Pius, can you tell Pius to mute so that we are in class properly? Okay, thank you. May I have someone who can take us through this question? But before maybe you take us through, I can ask a few questions. From what our agreement is, we have agreed that the vector equation of a line is R equal to, this I'm writing is already a solution. R equal to A plus lambda b. Okay. And we agreed that we can write this equation as long as we know the position vector of one point and the vector part of the line. Let me ask, when you read this, can you identify the A? And can you identify the B? If someone can, put up your hand and give them to us. There are people who never put up their hands. Should I go ahead and just speak? Ambrose, now you are with us. Can you identify the A? Tayewa. Okay, Biamukama. Victor?
I think A is 3I plus J.
What are you giving me? The A?
A is 3I plus J.
Is it plus J, Kato? Tayewa. Is that Tayewa? Yes. It is 3I plus 2J. What? Plus 2J.
2J, I'm sorry.
2J. Thank you. Okay. Biamukama Victor, can you give us the B?
B.
Okay, Joan, go ahead. Okay, some people's
J. Atija? Yes. Thank you. Welcome. Don't know how to reply.
Okay. Biamukama seems to have an issue. Yes, Joan? Joan, when I mute you, you unmute. I'll take you out of class. Please mute when you come in. Okay. Can we move on? I said Biamukama has a problem because he is not talking. I don't know why. Can I have someone else? What is vector B, please?
Vector B is 2I minus J.
Jazira says vector B. Is that Jazira?
Yes.
Is 2I minus J. Thank you very much. And that is the important thing. The moment you identify those two vectors, then the rest is feed in the formula. So required equation of our line. What is the required equation of the line? Can someone give me the required equation of this line? Joan?
Question.
Kato?
Teacher, I joined a little bit late, but I have just one question that which could we use to identify vector A and then B?
We are using the wording. If you go back to where we came from, what did we agree on? I don't know whether you was, okay, you must be seeing my screen. But if you go back to where we got the equation, hopefully you are seeing that screen now. We said A is the position vector of one point on the line. Now go to our work. When you read the question, what is it telling you? It is telling you that the position vector, find the equation of a straight line parallel to 2I minus J. That's not the position vector of a point on the line. That's the vector parallel to the line. And when I ask for B, B is the vector parallel to the line, then that is why you are giving me 2I minus J. And when I ask for the position vector of one point on the line, it is so clear which passes through, you are reading those statements, which passes through the point with the position vector 3I plus 2J. So Kato is just following the wording in our work. And everything is okay.
Okay, teacher, I get you now.
The wording. So what do I expect you, Kato, to master today? What I expect you to master today is that the A is the position vector of 1 point on the line. The A is the position vector of 1 point on the line. That is important. So when you read the question of 1 point, when you read the question, you should be able now to say, is this position vector of 1 point on our line? And then you say that is there for A. What about B? B is a vector parallel to the line. A vector parallel to the line. So when you read the question, you look out for the vector parallel to the line. And the moment you get it, that is our B. So I expect you to get the definition or the description of A and B. Okay, now I'm back.
Yes, thank you, teacher.
What did I want? What is the equation of the line? Can someone give me the equation of the line? Frank? Frank, I can't hear anything. Could it be network?
Equation of the line is R equaling 3I.
R equal to 3I plus 2J. Beautiful.
Plus
lambda.
2I.
Yes. 2I minus
J.
Very good. That is our answer. That is what we want. R equals to 3I plus 2J, which is the position vector of 1 point on the line, plus lambda 2I minus J, which is the vector parallel to the line. Noble?
Yeah, teacher, I have one question.
Please go ahead.
I was just inquiring about leaving, can't we leave the initials like the I and J?
And we write what?
Like we just write, like writing it as a vector, then we say 3, 2.
Writing column vectors. Very okay. I have no problem. Please go ahead and write R equals to the vector 3I plus 2J is 3, 2, plus the scalar. Then the vector, the other vector is what?
2, -1.
2, -1.
1.
This equation for the line is the same as the other. Those two equations are the same. Is that fine? Any
Yes.
other, do you have any other thing to say? Frank Kawesi, please mute. Whenever you come in, you mute. Okay, do we have any other thing, anything else that you have noted? Okay, then this allows me, please allow me to say that if I asked you to give me other points on this line, if I asked you to give me other points on this line, just vary the value of lambda. For example, when I take lambda to be 0, my R will be 3, 2. That is position vector of one of the points on the line, and that one you already know because that's what the question says. So the point with the coordinates 3, 2 is one of the points on this line. The point with the position vector 3, 2 or 3I plus 2J is one of the points. But I can get other points on the line by simply varying lambda. For example, when I say take lambda to be 1, I'll get R equals to 32 plus 1 into 2, -1. When you simplify this, someone can simplify this for us. What do we get?
R is 5.
5, 1.
5, 1. Now, the point with the position vector 5, 1 is also a point on the line. Or the point with the coordinates 5, 1. So you must know what you are giving. 5, 1 column vector is position vector of one of a point on the line. Or another person can say the point with coordinates 5, 1 is another point on the line. Now, if I tasked each one of you to give me 1 point on the line, coordinates, and in fact, I want coordinates of 1 point on the line, can I have some answers? Please go ahead and get coordinates of points on this line. I'm waiting for answers. On this line of ours, can you get me coordinates of other points? Anyone there? Please put up the hand and give me the point in the line. That's Otala. Otala, please go ahead.
4, -2.
4, -2. What lambda have you used?
2.
When you use lambda, when you use 2, what did you get?
4, -2.
Please go ahead and add, because I want you, when you look at our equation, it is R equals to 32 plus.
Okay.
Now you have only got 4, -2. That's not a point on the line. Can you now give me the point on the line? Otala.
Then it's 7, 7, 0.
So the point with that, but I wanted coordinates, so you will give me 7, 0. Thank you. Thank you. Otala, we are there. Angel?
Yes, teacher.
Angel?
Yes, I'm here. When I use lambdas 5, I get 13, -3.
When I use lambda is 5, I get 13, -3. That's another point on the line. Beautiful. Kato?
When I use lambda as 10, I get another point of coordinates 23, -8.
23, -8. Beautiful. Kawes.
Master, when I use lambda as -1.
I like that. Lambda is -1. I know very many people would do. Run away from the negative. But our lambdas can be positive, they can also be negative. Sorry for that. Go ahead.
The point is 1,3.
The point is 1,3. Did you say so? Beautiful. So we can get as many points on our line as possible by simply varying the value of lambda. Okay, let me give you a chance. These guys had put up their hands. Winnie, go ahead and give me your point, and Patience will follow.
My point is -1,4.
What
when
lambda?
When lambda is -2.
When lambda is -2,
Yes.
-2 gives you -1, correct? -2 gives you 4. And finally, Patience. Patience.
When I use lambda is equal to 3, my coordinates are my points 9 and -1.
9, -1. And so we can get as many others as possible. So like we get, like we have straight line and you can get as many points as possible. Even here, they are infinitely many. You can't finish. You can't give me all the points and finish them. If you notice, we have used the lambda is 0, lambda is 1, lambda is -1, lambda is 2, -2, 3, -3, 10, 5, you. We haven't even used a half. So very many I can use a half, a third, a what are they? And a lot of points on the line. So you cannot list them and finish all of them. Why don't I give another example? Are you seeing my screen?
Yes, teacher.
Is the example there?
Yes, it is there.
A volunteer to read for us the example.
Yes.
Someone was asking, which book is this where we are getting this work? I am using Sadler and Thorning, Understanding Pure Math, that red book that you always use. Understanding Pure Math, Sadler and Thorning. Okay, we continue. A volunteer to read for us? Patience? Okay. I seem to have lost the patience. Can I have Otala?
Find the vector equation. Find the vector equation
of the straight line that passes through the points A, B, and C. Given that the position vectors of A, B, and C are -1, 1, 2, 7, and 3, 9, respectively.
Very good. Thank you very much. So in our solution, I am free to begin by quoting my general equation. What is my general equation? Instead of my general equation being y is mx plus c, which we use in Cartesian coordinates, now my general point is r equal to a plus lambda beta, lambda b. You know what lambda is, you know what stands for. It's the general point. That's why you have seen R has been giving us different points on this line. It's general, it can be anywhere depending on the lambda. Okay? Then what is my A? Position vector. What is my lambda? It's just a scalar which can take on any value. What is my B? It is the vector parallel line. Let me ask one question. So when you read this question, can you identify A, the position vector of one point on my line?
Yes.
Yes, Mugabe, go ahead and give me what A is.
A is -1, 1.
That is Mugabe. Any other? Any other person? Yes, Innocent?
The points are A since they pass through the line.
Come again?
All the points are vector A since they pass through the line.
So should I use all of them?
No, we just pick one.
You can pick any one of these three. I think I like that answer. Otala's answer, who was that? Was correct, -1, 1. But I can even use 2, 7. I can even use. So any of these is position vector of one point on the line. That is more general, and I think I like that. Thank you very much for that submission. Okay, can we now move on? I have my A. Okay, who is choosing for us the A to take for this particular case where we can have very many? Winnie?
Let's take A to be 2, 7.
Let's take 2, 7. That is what Winnie is telling us. And now, The other that I need is the vector parallel to my line. This is a straight line. And my straight line you forgive me and take it that that is a straight line. My straight line goes through points A, B, C. Can we identify vector B? Winnie, did you not lower the hand or you have put up the hand again? Okay, Winnie lowers. Jason. Jason lowers. Angela. Angela.
I think BC.
Angela says BC. And what is BC? What is BC? Angela, you are discussing within class. Angela, you are discussing within class.
It's OC minus OB.
It is OC minus OB. Thank you very, very much. You are going to get a chance to ask, don't worry. What is OC? What is OC? Emma?
3-9.
3-9. And what is OB?
2-7.
2-7. So our vector is going to be the vector. Our vector will be the vector. Mugabe.
1, 2.
1, 2. Beautiful.
Teacher.
Now, may I ask someone to give us the vector equation of this line? May I ask someone to give us the vector equation of this line?
R is equal to?
R is equal to, so the equation of line is R equal to
2,7 plus lambda 2,
1, 2. Was it not 1, 2?
1, 2.
1, 2, not so?
Yes.
1, 2, yeah.
1, 2, 1, 2.
This is the equation of our line. Okay, may I have contributions? Someone who wants to say something, Winnie? What would you want to say? Watala?
Teacher, I thought, yeah, maybe if you had picked point A to be the point on the line,
yes,
we're meant to BC as the position vector.
Yeah.
But
then,
for this one, we have taken teacher.
This time I have picked B or B.
Yes, you've taken B to be the point.
Can someone
Again, you have used
answer?
the BC.
Can someone answer, Emma?
I'm also supplementing on his point.
Okay, you supplement.
Because initially we are taught that if you pick that point, for example, we picked B. Yes. So the line that we are supposed to use was supposed to be SC.
Who said so? Because you are saying initially we were told there's something like that. Is that what I heard? Who told you? Okay, like we have said, I don't remember who said it. Sometimes I try to recall the names when they, someone told us that we can use either A or B or C, even for vectors parallel to our line. If you looked at this line, vector AB is parallel to the line. Vector BC, which this younger girl picked. Can you give me another vector parallel to this line? Benji?
Vector SC.
Vector SC. Now, there is no particular vector that you are going to use at any time, at a given time. You are free to choose any. I don't know whether that answers the question. So I can have the answer as R equal to, the 2, 7 can be maintained, no problem. And I have lambda and I have vector SC. That doesn't make the first one wrong. That is right. The first one is also right. Please get me the vector SC. What is the vector SC? In fact, let me now change the scalar so that it is not the same scalar since I'm changing the what? Let me use mu. Since I'm changing the vector, and I'm showing you that these are different equations, but they are the same. So the equation, what I can say, the equation is not unique. Everyone is not going to get the same thing, but they are representing the same thing. Winnie, you have something to say? You have gotten for me, SC?
Yes, vector SC is 4, 7.
Is 4, 7. This is very correct as well. Now, if you want to know that it is correct, try and get points on this line. If I use lambda is 2, in the first line, is 2 the one that will give me what I want? Use 3. Use 4. If I use lambda is 4 for the first line, what am I going to get? What point do I get? I get 2, 7 plus 4 what? 4, 8. True, false?
4, 8.
What point is that? 6,
6 plus
6.
6, 15. Now try and use, I wanted you to use mu is 1. When you use mu is 1, what do you get?
Mu is 1. 6.
You get 14, which is not what we got there. To me, what is this telling me? This is telling me that someone has a problem here. Can you go back and check the vector SC?
Let's first see the question.
Okay, go back and check vector SC.
3, 9.
3, 9, negative 1, 1. Not so? 3, 9.
8.
Minus negative 1. 1.
Oh, teacher, it's supposed to be 4, 8. 4, 8.
Not so? So let's go back here and write the equation properly. 4, 8. That is all. That is the only thing I could find in that I could see there, because it was actually 3, 9. Wait a little. 3, 9 plus 4, 8. And when you use mu is 1, oh, where's my pen? I've lost the pen. When you use mu is 1, you are going to see that the point 615 is on this line. So you will see that they are the same points. These lines, the two equations that we are writing, have the same points. So they are equations of the same line, but they are not unique that they are all going to look alike. No. So you can use anyone for the point and you can use anyone for the vectors parallel to the line. I hope I've made myself clear. Winnie, can you tell those people to give you an opportunity to attend the lesson? Noble, say what you want to say, then we can go to example 19.
Now, teacher, assume you're given, at times if you're given, let's say I plus 2j plus 2k, giving the vector equation, okay, giving the vector.
You give the same thing, as long as it is in 3 dimensions. We are going there, but it's the same thing, it doesn't change. I'm going to give those examples. You
Okay,
don't have to worry. Can you read for us this one?
Show that the point with position vector I plus 2j lies on the line L. Vector equation R is equal to 4I minus j plus lambda into brackets 1 minus j.
Thank you very much. The line is R, and it is equal to 4I minus j plus lambda into I minus j. And we are told to show that the point whose position vector is I plus 2j lies on this line. If I may ask, can someone guide us? What do you think we want? Angela, can you see my screen now? Angela, can you see my screen now?
Not yet.
Can you play with your phone? Are you using your phone?
Yes.
Can you get the different screens? Because I know your phone has different screens. Swipe either left or right, and I'm sure you'll get there. Okay. What do you think we are going to do in this case, Kovia?
I think that we are supposed to find the value of lambda, and if it's constant for the I coordinates and the j coordinates, then that means the point lies on the line.
Those claps are yours. I hope you got them.
Thank you.
When our duty is to find the lambda. And as long as we could find a lambda that is giving us that point, those coordinates, or that position vector, then we have proved. So she's saying, what do we do? Get this position vector. We said this is general. Substitute it for R. So you are going to have I plus 2j. And this is 4I minus j plus lambda I minus j. How do I get lambda? Get 2 equations. In this case, there are 2 equations. If you write position vectors, you will see the equations very easily. But even if you don't write position vectors, equate, when 2 vectors are equal, we equate the components. Oh, sorry. When 2 vectors are equal, we equate the components. So we are going to get I, and I here, and equate them. So what does that mean? This implies that I is 1, 1I is equal to 4 plus lambda. Definitely from this, we can find lambda, and I'm sure you're going to find it. Also equate the j's. Let me connect it to power. Give me just a minute, my battery is down. Okay, sorry about that. I had forgotten to charge, but I think I'm now safe. Also, do what? Equate the j's. So you are going to equate this to this and that. Remember that has this part also. Okay, so what are we equating? Can someone guide? And
2.
And
Two
the
equals.
2 equals to?
-1.
-1.
Minus lambda.
Minus lambda. And from this, you are also going to get a lambda.
As -2. -3.
Can I have the lambda in the first place? What is the lambda in the first place?
5.
Lambda is -3.
-3. And can I have lambda in the second place?
-3.
Because the lambda is consistent for the two equations that we came up with here. Lambda is -3 is consistent. Because of that, we can then comfortably say the point lies on the line. If the point does not lie on the line, lambda will have different values. When you create the components, the I components, you get something different from when you create the J components. So make a conclusion there. Lambda is -3 is consistent in the equations that follow. And so the point lies on the line. Joanne, you want to say something? Please say it.
No.
You don't want to say anything? Can you close your mic? Winnie, Ambrose, close your mics because we can hear those children. Is it that some people don't know how to close the mics, but how do they open them? Please keep the mic open, closed until when you have something to say. An example. I'm there already. An example. I'm there already. Someone to read for us. Angela, did you succeed viewing my screen?
Yes.
Oh, beautiful. Okay. Joanne, please read for us the example. TechnoSpark 4, I told you to rename. But can you go ahead and read the example? Your mic is already, oh, okay. Oh, Joanne, you have opened. Joanne, you have closed. Okay, Winnie, go ahead.
Find the position vector of the point of intersection of the lines L1 and L2, given that L1 and L2 have vector equations of R is equals to 2I plus J plus lambda into I plus 3J, and R is equal to 6I minus J plus mu into I minus 4J respectively.
Thank you. Allow me to use this other screen. That is example 20. I've not shared my screen, a new screen. That's example 20. Find the position vector of the point of intersection of the lines L1 and L2 that are given by R. So I can give you the first line. Equation of that line is R equals to 2I. Can someone read for me? Plus J plus lambda
plus
into I plus 3j.
I plus 3j.
Plus 3j.
Thank you. The second one is R.
Is equals to 6I. 6I minus j plus mu into I minus 4j.
I minus 4j, thank you. Okay. Find the position vector of the point of intersection. How do we get the point of intersection?
At the point of intersection. At the point of intersection.
Yes. What happens?
L1 and L2 are equal.
Very good. I don't want to say L1 and L2 are equal just, but that is one way. But what I want to say, to mention as standard, is that for points of intersection, we solve equations simultaneously. It is not changing. That's how we have been handling the other Cartesian equations. It is the way we handle these ones. We solve the equations simultaneously. One way of solving simultaneously is equating, because both of them are given in terms of R equals R equals. If you are handling the same number, then don't use the same scalar. That's why you are seeing in one equation the scalar is lambda, then in another the scalar is mu. Don't maintain the same scalar, because if you maintain the same scalar, it's as if the scalar that is working there is the scalar that is working here, which is not true. So vary this, change the scalars for the different lines that you get if you are handling the same number. But in this case, we are saying all, I keep mixing up names. I'm sorry. I don't remember who it was who said equate, because both of them are equal to R. Please go ahead and equate. It is easy to work with column vectors. Please allow me to use column vectors. This is 2, 1 plus lambda 1, 3. And this is equal to 6, negative 1 plus mu 1, negative 4. Two vectors are equal if the components are equal. So equate the I components. So this will imply that 2 plus lambda equals to 6 plus mu. This is equation 1. What else does it imply? What else does it imply?
1 plus 3.
1 plus 3 lambda.
1 plus 3 lambda
is
equal
equal
to
to
negative 1 minus 4 mu. This is the second equation.
Minus 3.
Solve the equations and get the scalar. Now allow me to say, okay, solve the equations and get the scalar. So I'm going to wait at the scalar point, at the point of the point of scalars. Get the scalar. Those are the equations. Please find the scalars.
3 lambda plus 4 mu negative 4 minus 1 get negative 5. Oh, sure. Slowly. 3 lambda minus 3 mu equals to 3 lambda plus 4 mu equals negative 5. Negative 7 minus 5. Negative 7. 12 minus minus 5. 17. 12 negative 10.
Janita, you are misbehaving. Kato, are you there?
Yes, teacher, I'm there. I'm
Please
there.
go ahead. Go ahead.
Lambda equals to 2.
Lambda equals to 2.
And the mu is equaling to -2.
And the mu equals to -2. That is what Kato is saying. I want to believe that that is correct. -2 will give me 3 in the second equation for mu. Huh? Will give me 7. And the 2 will also give me 7. For the first equation, lambda is 2 will give me 4. And for the first equation, -2 for mu will give me 4. Beautiful, that's it. Now, what am I supposed to use? Okay, can we now answer the question? Mulongo Kato. The question was, find the coordinates of the position vector of the point of intersection. So, what is the answer that I'm going to give? Or how do I get to the answer? Yes, Joan?
And substitute in one of the equations the value of the scar and want. Like if we substitute in lambda, the position vector.
So we are going to have 2, 1 plus the lambda, which is 2, into 1, 3.
Yes.
This is our R, by the way.
Yes.
And when you work this out, what do we get?
You get 47.
You get 47.
Yes.
Or we can substitute mu. 6 -1 minus 2 1 -4. This is our R.
Yes.
And what does it give to us?
That's all.
47. So for this question, the position vector of the point of intersection is 4, 7. Remember, it is a position vector. Either you are giving the column vector or you are giving the ij notation for I plus 70. However, sometimes the question may ask for the coordinates of the point of intersection. Can someone give me the coordinates of the point of intersection? Can someone give me the coordinates of the point of intersection? Joseph, you are in class. Joseph.
I'm sorry.
Yes, Winnie, go ahead.
The point is, the coordinates is 4,7.
4,7. Beautiful. So be keen on what the question requires, because you have the answer, but give it in the form that is required. If it is coordinates, give the rightful form of coordinates. And if it is position vector, give the vector. Now I am asking, before you ask, now answer my questions. Is it necessary to get both lambda and a mu, the values of both?
No.
Yes.
No, it is not. You can get one of them.
You notice that when you have lambda, you have the point. When you have mu, you have the point. So is it necessary to get both? No.
No.
Any one that you have got will give you the point of intersection. You just know. Exactly. You just know if I have got lambda, I substitute in the first equation. If I have got mu, then it is the second equation. Not so? Very good. Okay. Sorry. And any other question? Oh, no. If you have any question, please go ahead and ask. If you don't have, I'm sharing my screen once again, and I'm sharing with another example. Can you imagine?
Find the vector equation of a straight line that passes.
Go ahead.
It is perpendicular to the line.
Winnie, you were reading, I thought.
Oh, find the vector equation of the straight line that passes through the point with position vector 2i plus 3j, and which is perpendicular to the line. R is equals 3i plus 2j plus lambda into I minus 2j.
Very good. Very good. Do I have to say? Yes, teacher, you can say so. What is it? That the solution, our R, the vector equation required is? Give me the equation that is required. Generally, it is A plus what?
Plus lambda B.
Plus lambda B.
Lambda B. What is A standing for?
Point on the line.
Position vector of 1 point on the line. Do we have it given in our question?
Yes.
So what is our A in this question?
A is 2.
It is 2i.
2i plus 3j.
Plus 3j. Very good. Is B given in our question? What is B? Okay, let me now take you back. The vector is perpendicular to the line, or the other line. The vector B is perpendicular to this line. Have you noted the equation that I have just underlined?
Yes.
Good. So do you notice that from that line, you can give the position vector of 1 point on that line? What is the position vector of 1 point on that line? Very good. And what is the vector parallel to that line?
I minus 2j.
1 minus 2j.
I minus 2j. So we do not know the vector perpendicular to our line. But what we know is that this vector B is perpendicular to this line. And for it to be perpendicular to this line, it means that it is perpendicular to the vector that is parallel to the line. So B and the vector parallel to the line, I minus 2j, are perpendicular. B and the vector parallel to the line are what?
Perpendicular.
So what is our duty? Our duty is to find B. I can take a B to be the vector xy. And the other vector is the vector I minus 2j, which is 1, negative 2. When I dot them, what do I expect to get?
X negative 2.
I get a 0. Why do I get a 0?
Because they are perpendicular.
Because they are
perpendicular.
Now, use that equation and get x and y. X dot 1 will be x. Y dot negative 2 will be negative 2y, and this is equal to 0. I am free to carry over this to the other side and write that x is 2y. Now, what is the vector B? The vector B is the vector xy. My x is 2y. My y is y. So when I factorize the y out, I get the vector 2, 1. So all vectors that are parallel to 2, 1, all the vectors that are parallel to the vector 2, 1 are perpendicular to the vector 1, negative 2. So I can take my B to be 2, 1 when Y is 1. I can take my B to be 4, 2 when Y is 2. I can take my B to be negative 2, negative 1 when Y is negative 1, and many other values of my own choice. But the most simplified is the 2, 1. So the moment I get my B as 2, 1, then it means I can go back here and I write that my B is the vector 2, 1. And then I can substitute that in the equation. And I'll have the vector equation of this line that I'm looking for. Can someone give me the vector equation of this line? R is equal to our A. Our A was the 2I plus 3J, not so? Our A is 2I plus 3J plus a scalar of our own choice. Lambda and mu are commonly used by our books. Then plus times B, the vector parallel to this equation, to this line, and it is perpendicular to the other line. And that is what we have gotten here as 2I plus J. So I can give that equation. But another person who gives here that it is 2I plus 3J plus lambda, please be careful, it must be equal to R. There is no equation if it is not equal to anything, because the word equation means equal to, it is coming from those equality signs. So if I just start from 2I plus 3J, that's not an equation. I should start from R equals. And I'm forgetting now what this one is. No. A person who uses 4 and 2 is also correct, because these two are parallel. The moment you pull out the scalar 2, you get that. A person who uses the other vectors parallel, like 6, 3, and so on and so forth, they are all correct values of our equation. This is the most simplified one. It's what I would personally go for. But that doesn't stop you to go for what you want. Winnie, you want to say something? Your mic is open.
Yes, I'm getting confused.
Winnie, you are not getting confused. Can you rebuke it? In
Okay.
Jesus' name.
In
Yes.
Jesus' name, amen. Okay,
Go ahead.
I'm not understanding where this second equation is coming from. The first one, the one you've done a box, I'm okay with it. But this second one, where 4I lambda into 4I plus 2J, is that the other value of B or?
Winnie, are you there?
Yes, I'm there.
We have said that two vectors are parallel if, when are they parallel?
When their dot product is equals to 0.
Parallel?
No, parallel. That is
so when the angle between them is 90.
Parallel?
One is the scalar of the other.
One is a scalar product of the other. And we said, so when I have A equals to scalar K times B, then vector A and vector B are parallel. Is that fine? So yes. What is it that I want to say here? What I want to say here is that when I took the values of Y and divided them, when I multiplied by 2, I got 4,2. 4,2 is another vector parallel to 2, 1. So since both of them are parallel, they are both parallel to the line. And I can either use 2, 1 or 4,2. That is what I said there. I also said that it is also parallel to -2, -1 when y is taken to be -1. So I can also use this one. So Winnie,
Yes.
you will not be confused, and you can never be confused when I write 2i plus 3j plus lambda, and this time I write -2i minus j. -2i minus j is parallel to 2i plus j, so they are both parallel to the line. And remember, this is a vector parallel to the line, so I can use the other, I can use this. There is not one single vector that you can say it is the only vector parallel to my line. No. There are very many vectors parallel to the line. So you can use any of them. I have said that even when you put in scalar 3 and you get 6i plus 3j, that one you can also use, etc, etc. So in this vector work, you will find that some people are not exactly giving what you have given when they are correct. As long as you understand that those vectors where you are saying, now these ones are parallel, now this is another point on the line, you can state the answers. The answer may not look exactly the same, but they will be representing the same line. If there's nothing that you are saying, then why don't I answer 22? And then I give one other one in 3. Okay, let us answer 22. Very fast. I'm looking at the clock, and the clock is going and is running. I can't believe it. But no, I can believe it. We didn't start on time. We were not, we didn't start at exactly at the dot of the hour. Okay, please go ahead. Someone read for us and we go through it. Then we shall give another, find the perpendicular distance. How should we get the perpendicular distance of this? Find the perpendicular distance. How do you get the perpendicular distance? Is someone there? Am I here alone? Find the perpendicular distance from the point A, whose position vector is what? Whose position vector? Yes, Otara?
I think we should get the coordinates of the point where the line, okay, where the coordinates of the first point A and where it touches the line to get the distance.
Now this is the line whose equation is given to us very clear as R is -3, 1 if I write column vectors plus lambda 1, 2. That's the equation of the line. Now we are given point S. We are given point S somewhere with the coordinates 4, 5. What is the perpendicular distance of A from the line? This is the distance that we would want you to find. That is the distance that we would want you to find. Now, please allow me to be I want you to be careful as you work out this. What are you going to say? You will say that there exists a point, say Q. Let me call mine Q. There exists a point Q on the line where the perpendicular from A will meet the line. There is a point Q on the line where the perpendicular from point A will meet the line. So I don't know the coordinates of that Q, but I am sure that it exists. So what do I need to find? Get vector AQ. And the moment you get vector AQ, the required distance is the magnitude of AQ. The required distance is the magnitude of AQ. So can we go ahead and work out this? Yes. How am I going to get AQ? If you look at the diagram properly, you will notice that vector AQ is perpendicular to the line.
Excuse me, sir. Your screen is
Excuse
paused.
me, sir. The screen has been paused. You are not seeing.
Which screen? Did I not share my screen?
No,
Yes,
you
we
did
are not seeing anything.
I'm
We are
sorry.
just seeing the example.
I'm sorry. I am sorry.
Now, sir, you see?
I am sorry.
So now you begin. You begin afresh. Begin afresh.
No, I'm not going to begin afresh. I'm only going to say this is the question. So I just told you that the equation of my line is this one. That is my line. The equation is given to me. I only wrote it in column vector because I and J are very many and they are sometimes hectic to write. Not because I'm changing it for another reason itself. It is still the same equation and it is still simple. But I, J are many, it is easy to write column vectors. So I wrote it using column vectors. Now I said, my point A, as you see it, is not on the line. And they are asking me for the distance from A to the line. That distance must be the perpendicular distance. So that's why I drew that perpendicular. And I said, there exists a point Q on the line where the perpendicular from A meets the line. Now, our duty is to find AQ. And if we get its magnitude, that is the distance that we are interested in. So I said, AQ is perpendicular to the line. Now, Win, tell me what you want me to repeat.
I've understood.
Now I can continue.
Yes, you can continue.
Thank you. Now, when I say that AQ is perpendicular to the line, what mathematical interpretation comes to your mind?
The dot product is 0.
The dot product of AQ and what?
And the direction vector of the line.
Very good. This AQ, Madam Winnie, is perpendicular to the line. The dot product of AQ and the vector parallel to the line, we usually call it our B. We have been using B generally. AQ and the B. When you dot them, you get 0. Very, very good. Please go ahead and dot AQ and B. So AQ dot B will give me 0. What is AQ? It is OQ, which I don't know, remember, minus OA.
Okay.
Which I know, not so?
Yes.
Dot B. This is 0. Okay, go ahead and feed my equation with the A. Give me the A and also give me the B.
A is
And
negative 3, 1.
So OQ minus Winnie, where is negative 3, 1 coming from? Be serious. OA is the point 4, 5.
Oh, 4, 5.
OA is the point 4, 5. Now, when you subtract those two, and you dot with the 2, was it 1, 2?
1, 2, yeah.
1, 2. This gives you 0. Can we rush a little bit? I'm going to move a little bit fast. The OQ, I'm going to call it XY, or should I call it AB? What do you want? XY, X minus 4, Y minus 5. Dot this with 1, 2, and you get 0. Please, when I multiply by 1, I will get X minus 5, not so? Plus, when I multiply by 2, I'll get 2Y minus 10. And this is equal to 0.
X minus 4. X minus 4.
X minus 4, not 5.
Minus 4.
X minus 4. Thank you very much. Thank you. I'm looking for my pen now so that I can wrap. Am I not in trouble? Does that make sense to me? Okay. Let me leave it at that. X minus 4. X minus 4 plus 2y minus 10, which I can write as x plus 2y minus 14 equals to 0. There's something that I skipped here. What is it that I skipped? Point Q lies on the line. And if any point lies on the line, what does that tell us? It tells us that it satisfies the equation of the line. So the vector OQ, actually I want to take you back and take away the XY. You forgive me for that. I want to take you back because when I use XY, it's not easy to come by the answer. It's not as fast. So I'm taking you back there. Q is a point on the line. Q is a point on the line. Because Q is a point on the line, it satisfies the line, and so OQ will be equal. So go to the equation of the line and put in what does that tell us? It tells us that there is a value of scalar, and there is a value of the scalar. You remember when we vary these values, we get different points. Do you remember that?
Yes, sir.
So what does that tell us? It tells us that there is a certain value for this lambda, which will give us OQ. But we don't know that value. We don't know that lambda, that value. So let us take it to be just lambda 1. There is a certain value of lambda, which we shall substitute in this equation, and we get OQ. So our OQ is going to be negative 3, 1 plus that lambda into 1, 2. So our OQ will be negative 3, 1 plus that lambda, I am calling it lambda 1 into 1, 2. So use that in our equation and subtract the 4, 5 and dot with 1, 2 and equate to 0. So what am I going to write finally? Finally, I'm going to write, are you noticing I'm going to substitute it where I have OQ? So I'm going to put there negative 3, 1 plus lambda 1, 1, 2 minus 4, 5. So I write negative 3, 1 plus lambda 1, 1, 2 minus 4, 5. All of this dot 1, 2. This is going to give me 0. This will help you to get lambda 1. Okay? So add all the top ones. -3 this one, and -4 this one, and lambda. So I'm going to get lambda 1 minus 7. Then the bottom ones, this is 1 and this is -5. So I will get 2 lambda 1 minus 5. All this dot 1, 2 will give me 0. Please go ahead and dot. When I dot, what do I get? When I dot, I get 1 times lambda 1, which is lambda 1 minus 7 also. And when I dot by 2, I get 4 lambda 1 minus 10. And this is equal to 0. Collect like terms. Lambda 1 and this. Doesn't that mean I've made a mistake somewhere?
Yeah.
Where? Is -7 -7?
It's -6.
How? How does it become -6?
Then you see that this vector of 1, 2 minus the vector of 4, 5.
No. We first multiply and add. So me, I added -3 and 7. I am not seeing any mistake, but I am seeing an ugly answer. That is why you see me complaining.
Teacher,
I'm seeing an ugly answer for what? I'm seeing an ugly answer for lambda 1. What did you tell me? OQ minus OA. That one I have no problem. That is the AQ. The AQ is perpendicular, and therefore that is 1, 2. And then the 4, 5. Oh, that is correct. Q is a point on the line, and therefore there exists a value. That's -3, 1 plus that. I'm not seeing anything. I'm seeing ugly answers.
Teacher.
Yes. Have you noted anything?
Instead of -5, it's -4.
Instead of?
Instead of -5, it's -4. Like 2 lambda
It's alone to 0, and then the J is alone.
Okay. Someone is helping me there. I see what your point. Thank you very much. Because my answer is ugly. And for me, I don't expect ugly answers. One of the qualities of an answer, it must be beautiful. Not so? So this is 1 minus 5, which is -4. Is that right?
Yeah.
So that one makes now this value here to become what? Become -8.
8.
Oh, very good. Now I can see when I add lambda 1 and 4 lambda 1, I get 5 lambda 1. And when I carry this over, and I also carry this over, it gives me equal to what?
15.
Yeah, that is more beautiful. So what is lambda 1?
3.
Lambda 1 is 3. Now, where am I taking that 3? I'm taking that 3 somewhere. I can put it here, but I can put it in this bracket. Because I want you to remember what we want. We want AQ. What is our AQ? Our AQ is this whole bracket, OQ minus. This whole bracket is our AQ. OQ minus OA, which is this one simplified. And so our AQ is lambda 1 minus 7, 2 lambda 1 minus 4. Please substitute the value of lambda 1 that we have gotten. If you put in the value of lambda 1, the 3, this will give me 3 minus 7. This will give me 6 minus 4. And what answer do you get finally?
-4
and 2. Is that right?
Yes.
Yes.
What is the distance? The distance is the magnitude of AQ. And please, what is the magnitude of AQ? -4 squared plus 2 squared square root. Give me that value finally. 16 plus 4, root of 20.
Root of 20.
Of course, root of 20 for you who know studies is 4 times 5, and it can be root 4 root 5, which is 2 root 5. Now, I didn't check on our, but that is, you are going to go back and slowly check and make yourself comfortable. I'm sorry I passed the time, but I'm not so sure whether you have a GP or something.
Root 5 units.
Units, thank you. Units. But another person can leave it at root 20. There's nothing wrong. I want to apologize for the time, but also I want to thank you for doing your best to follow. Okay?
Yes.
Okay, sir.
There are many other examples. Those who have the book, go there and look through. I have put that, these other ones, the one that was following, you will notice that it is not 23, but instead it is 9. It is from another chapter, which is now handling 3 dimensions. The equation is not changing. Someone asked me, what if it is 3 dimensions? Nothing changes. What if it is 3 dimensions? So you can take a picture of that and write the equation. But someone will tell you how you can write the equation very fast here because they are 3. And then you have lambda, and then you have also 3z. What is this? 3, 4, 1. 3, 4, 1 is the, no, 3, 4, 1 is the vector parallel, I'm sorry. 3, 4, 1 is the vector parallel, not so? And what is the vector that is the position vector? The position vector instead is 2, 3, -2. And you are done writing the equation of that line. So when we go to 3 dimensions, it doesn't make it different. It remains the same. We shall pick it up from there next time. I want to wish you the very best. May I have a volunteer?
Thank you, sir.
May I have a volunteer to lead us in prayer so that we close with a prayer we started with?
Bishop Emma, lead us in a prayer.
Who is Bishop
How
Emma?
can I get?
Bishop Emma, please. Someone had a question. How can I get that book?
Yeah.
Huh? Do you belong to our WhatsApp group? I'm going to ask Mr. Kaziba to share it with you on WhatsApp.
Okay, sir.
Okay.
You can get it from the WhatsApp classes. Okay. Can we have Bishop Emma now? It is your time.
Okay. And let's pray. In the name of the Father, of the Son, of the Spirit.
Amen.
Lord, thank you for this day. Thank you. Lord, you enable us to have this lesson today. Ask you to wisdom, understanding. Father, continue giving us the courage. Continue giving us the strength so that we may carry on that revision and our lessons continuously. Father, this year, ask for your grace, guide us, and be we pray. In the name of the Father, and of the Son, and of the Holy Spirit.
Amen.
Amen.
Thank you very much, Bishop Emma, and everybody for attending and being in there.
Thank you, Teacher, and God bless you.
Bless you too. Have a nice evening. Bye-bye.
Bye.
Hey. Matulenga na wedi na wensolo seka.